Trig. We are going to cover lesson 71, which is on the ellipse. Now, the ellipse is an oval-shaped graph, but the definition of it is it's the locus of points such that the sum, so here I have my ellipse. I have two foci, which is a focal point, and the distance, the sum of their distances to any point on the outside is always a constant, no matter where that point on the outside is. Like, for example, if it's over here or down here, it doesn't matter. It should be a constant. So there are two kinds, a horizontal ellipse or a vertical ellipse. So a horizontal ellipse will be, in standard form, should look like the following. X squared over a squared plus y squared over b squared equals 1. Now, in this case, I know it's horizontal because the letter A is the major axis. And in other words, it should be the larger number. B is the minor axis. So when I'm graphing an ellipse, the largest number, if it's located underneath x, that means it's being stretched across x. And so that is what's making it horizontal. Versus a vertical, you'll notice the difference, x squared plus y squared equals 1. The larger number is under y, and that's what stretches it across the y-axis. Now, in a later lesson, it'll go over how to find the foci. I am going to go over when the center, and they kind of slowly get us there, when the center is not at 0, 0, the formula looks like x minus h squared. Very similar to your circle. Y minus k squared equals 1. The difference is you have your a squared and your b squared. And in this case, the center is at h comma k. And they'll get there. They're nice. I'm like stuttering. They're really nice in that they slowly introduce an ellipse to you. So we're going to do a couple examples. So number 1. Graph x squared over 25 plus y squared over 9 equals 1. Now, when I look at this, I notice that the larger number is under x squared, so this is horizontal. And now I'm going to identify, I know my center, since there's nothing next to x or y, my center's at 0, 0. A squared is 25, which would mean A is 5. And B squared equals 9, so B equals 3. So I'm going to use these three pieces of information here, my center, A, and B. And I'm going to go ahead and find our foci, even though it doesn't ask, and I'll write this up here. The formula for our focal points, or foci, is c squared equals a squared minus b squared. Notice that looks just like the Pythagorean theorem with a slight difference. So I'm going to go ahead and calculate the foci. So my focus, so just like we did when we did the parabola, we had a focus and a directrix. I have a squared minus b squared equals c squared, so 25 minus 9 equals c squared. 25 take away 9, I believe, is 4. I could be wrong, but I'm pretty sure 25 minus 9 is 16. And so c equals 4. All right, so we're going to graph this. So I'm going to grab a ruler. Now remember, it's horizontal, So because the larger number is underneath x, so it's being stretched across x. So when I go to graph this, I'm going to make my x-axis longer than my y because I need to leave more room on x. All right, so I'm just going to label a couple, 4, 4, this is x, -4, -4. All right, so let's start. Our center is at 0, 0. So I'm going to put my pen at 0, 0. Now A is 5, so from my center I'm going to go to the right 5, and I'm going to go to the left 5. And those would be called our vertexes. Just going over all the pieces as I graph it. It also means that x is my x-axis, is my major axis because it's horizontal. So go back to the center. B is 3, so up 3, down 3. You can call these co-vertex or co-vertices. And it's like a co-captain because these are smaller. You went 5 in each direction and then you only went 3. You went 5 to the left and right, 3 up and down. So I'm now going to connect my ellipse. Remember, it has an oval shape. Just pretend you're doing 2 really wide parabolas. So there's my ellipse. And last is my foci. I'm going to go back to the center. 4 and 4. So that is, I have 2 focal points, and focus plural is foci. So that is your ellipse. So in this case, because it's horizontal, your x-axis is your major axis. My y-axis is the minor axis because it's shorter across y than it is x. All right, so we're going to do 2 more like that so you have a better feel for ellipses. So we'll do 2 more. And we're going to make it a little bit more complex, not a lot. So we're going to write in standard form and graph. And my equation is 5x squared plus 2y squared equals 15. All right, so here is our ellipse. Now, I know this is an ellipse looking at it because a circle would have to be all the same number. So they'd all have to have a 15. That's how I know they're being pulled or stretched in the same width or magnitude in each direction. But in this case, I have a 5 in front of the x and a 2 in front of y. So I know that this is an ellipse. One is being pulled less than the other. To get this in standard form, the right-hand side must equal 1. And so the only way to do that is to then divide everything by 15. So I then have 5x squared over 15 plus 2y squared over 15 equals 1. And then we're going to reduce. So that gives me x squared over 3 plus y squared over 7.5 equals 1. So there it is in standard form. And it's okay to have non-perfect numbers. So now I'm going to identify A, B, and C. Now remember, A squared will be the larger number. So in this case, A squared equals 7.5. So to find this, you're going to have to take the square root. So the square root of 7.5, I get 2.74. B squared equals 3, so take the square root, and the square root of 3 is 1.7. And then 7.5 minus 3 will equal c squared, so 4.5 equals c squared. So if I take the square root of 4.5, c equals 2.12. Now, because a squared is underneath y, this will be a vertical ellipse because the larger number is underneath y. So when I go to graph this, I'm going to leave more room on the y-axis versus x. Also, the center, there's nothing in parentheses next to x and y, so the center is at 0, 0. So I am going to deal with all of these numbers here. So I'm just going to make sure I have at least one number on my axes so we know our scale. So starting at the center, I'm going to go up 2.74, almost 2.75, and I'm going to go back to the center and go down 2.75. Okay, because these are our vertex or vertices. These are our co-vertices. And these right here are our foci. So there's my vertex. Here's a vertex. Go back to the center and go 1.7. So there's my co-vertices. Back to the center and the opposite 1.7. And then form your ellipse to the best of your ability. Okay. And then last is my foci. Now the foci should be in the same direction as our vertex, just like it is with a parabola. So my foci is 2.112, so there's 1 and 2.112. And that is your ellipse. Last one. Same directions, we're going to write in standard form. Hold on, sorry. And graph. So write in standard form and graph. So I have 4, I'll write it down here, 4x squared plus 9y squared minus 36 equals 0. All right, so I need that right-hand side to equal 1. So the first thing we're going to do is add the 36. So this is now 4x squared plus 9y squared equals 36. And then to get it to equal 1, I have to divide by itself. All my pens are dying lately. Hold on. And so I'm going to rewrite this. This is now 4 over 36 is x squared over 9 plus y squared. 9 over 36 is 1 over 4 equals 1. So this is a horizontal because the larger number is underneath x. So a squared equals 9, so a is 3, right? Square root. B squared equals 4, so b is 2. 9 minus 4 equals c squared, so 5 equals c squared. So if I take the square root of 5, hold on, and it doesn't ask you to do the foci, but I have you do it because you're going to do it in the future anyways. And my center is at 0, 0. So because this is horizontal, when I go to graph it, I'm going to leave more room on my x-axis than I do my y-axis. So here's y, here's x. I'm going to go ahead and label this. This is my vertices. These are my co-vertices. And these are my foci. So starting at the center, okay, I'm going to go 3 in each direction. To the right 3, to the left 3. Those are my vertices. I'm just going to label it with a V. Back to the center, up 2. Back to the center, down 2. There are my co-vertices. So again, I have a really small oval. And then last would be my foci. That wasn't perfect. And so it should be 2.2 in the same direction as your vertices. And that is it. Homework. You're going to skip numbers 1, 3, 5, 9, 13, 24, and 26. Sorry, you can't see that. Thank you.